Okay, good day everyone. So in this video, we're going to discuss about chapter 2, 2.2 structures and function, cell membrane and organelles. All right. In this subtopic, we have a few objectives that need to be achieved. However, I'm going to specifically focus on the third objective, which is to show the structure of plasma membrane based on fluid mosaic model. Meanwhile, the rest of the other objective will be discussed in your tutorial class. Alright, so before we start, I would like to do a bit of recap. So I hope everyone knows that animal cell and plant cell, both of them, consist of the plasma membrane. So what is the plasma membrane? It's a membrane that encloses a cell. So this is the structure of plasma membrane. It is the outermost layer of any cells. Okay, so the function is to control the movement of substance going into the cell or going out of the cell. So any substances that going in or going out of the cell, it needs to pass through the plasma membrane. All right. However, one of its characteristic, it is selectively permeable. So what does it mean by selectively permeable? It only allows certain substances to pass through it. So not all substance can pass through the plasma membrane. All right. It is also separate the living cell from its non-living surroundings. So basically, plasma membrane, it protects the cell from anything outside of it. Okay, since it is the outermost layer and it's very, very thin, it's normally about 8 nanometers thick. And since it is very thin, it's only composed by two major components. The first one is phospholipid and the second one is protein. All right. Okay, so if you want to discuss the structure of plasma membrane, a very detailed structure, we can do that by looking at the fluid mosaic model. Okay, so this model, the fluid mosaic model, was proposed by Seymour Jonathan Singer and Garth Nicholson in 1972. So based on Singer and Nicholson, they proposed that the membrane, the plasma membrane, is made up from two layers, which are phospholipid, the two layers of phospholipid and globular protein. All right, so this is how it looks like. There are structures that we call it as phospholipid, and there's another structure that we call it as phospholipid bilayer. So what is the difference between the phospholipid and phospholipid bilayer? So if we are talking about the one layer, that is what we call as phospholipid. However, if we are referring to two layers, hence we call it as phospholipid bilayer. Bi means two, so two layers. All right, so other than that, we have the purple structure here. This is what we call as globular protein. So globular protein, if you can see, it's embedded in the phospholipid bilayer. So two major components. The first one is phospholipid and the second one is globular protein. Okay, to move on, there's a reason why we call it as fluid mosaic model. So based on Singer and Nicholson, the word fluid is referring to the ability of the phospholipid to move laterally or flip-flop. So what does it mean by laterally? It can move from side to side. Okay? And flip-flop, it means it can move from upside to the downside and conversely. Okay, other than phospholipid, protein are also free to move laterally. Hence, that is why we call it as fluid. Okay, however, there's a reason why we call it as mosaic as well. So the reason is that the presence of various protein that embedded in the phospholipid bilayer. So as you can see, from the diagram here, there are the globular protein that embedded in the phospholipid bilayer. Hence, we call it as fluid mosaic model. Okay. So the component of the plasma membrane, we can divide it into major component and other component. Okay, so the major component, as you know, we have phospholipid and also the globular protein. However, we also have carbohydrates and cholesterol embedded in the plasma membrane. Okay. Alright, so let's look at the globular protein. So if you want to further divide the globular protein, there are two types of them. The first one is integral protein and the second one is the peripheral proteins. Okay, so what's the difference between these two? Integral protein is the protein that we find that is whether it is a partially embedded or fully embedded in the phospholipid bilayer. However, peripheral protein, we can find them when the protein is sit at the adjacent of the phospholipid bilayer. Okay, it's not embedded in the phospholipid bilayer. All right, so we have the few example of the fully embedded integral protein, which are carrier protein or also channel protein. Okay. All right, so this is the structure of phospholipid. As you can see here, there are structures that we call it as phospholipid, and then we have another structure which are globular protein. So globular protein, we can further divide it into integral protein and also peripheral protein. So if you can see here, integral protein is fully embedded in the phospholipid bilayer. However, peripheral protein is not embedded in the phospholipid bilayer. All right. Other than that, we have carbohydrates, the green structure here. Okay, and also cholesterol. Cholesterol is embedded in the phospholipid bilayer. All right, let's focus on the green things here, which is the carbohydrate. You can see here the carbohydrate is attached to the one of the globular proteins. So since it is attached to proteins, we call it as glycoprotein. Okay, if we look at here, the carbohydrates here, it attached directly to the phospholipid. Okay, hence we call it as glycolipid. All right. Okay, so I think that's all for fluid Mosaic model. We discussed all the structures here, which are the main component, phospholipid and also globular protein. Globular protein we can further divide into two, integral and peripheral, and other component which are carbohydrates and also cholesterol. So that's all. I hope it's helpful.